Triangle. The 7th chapter in the syllabus which we're going to deal with is triangles. Triangle. What is a triangle? In mathematics, we have a definition of triangle in its own manner. So let's see the introduction of a triangle. The introduction of a triangle. As triangle refers, clearly I have a triangle which is separated into tri plus angle. So a triangle is formed by tri and angle. Tri refers to 3. And angle refers to the angle which we have out here. So any figure which has 3 angles or a figure which has 3 angles involved is called a triangle. As we see, a triangle looks in the shape of this. It has 3 angles, angle 1, angle 2 and angle 3. So triangle has 3 angles, angle 1, angle 2, angle 3 is how we get the 3 angles in a triangle. Triangle, a figure which involves 3 angles, is what is called a triangle and looks in this shape: angle 1, angle 2, angle 3. So a triangle has 3 angles, 3 sides, and 3 vertices. So a triangle has 3 angles, 3 sides and 3 vertices. Study of 3 angles of a solid figure, of a geometrical figure, is what we refer as triangle. Now that we have discussed about the definition of a triangle or what a triangle looks like, we have next the properties involved with triangles. The first property is about congruency of triangles. Before we understand the congruency of triangles, let's try to connect the congruency definition with the triangle. What is congruency? Let's see the definition in brief. Congruency. What is congruency? Before we get into the actual mathematical definition, say for example, I have taken a picture of mine on a mobile phone. I have taken the picture twice. So this is my picture 1. And this is my picture 2. When I take the picture immediately, I see that both the pictures are similar, quite similar. Therefore, I say the picture clicked immediately one after the other are said to be congruent because they are exactly same to each other. Or say for example, I take a 1 rupee coin. Imagine I take a 1 rupee coin of the year 2013 and I take a similar coin out here of the different year, say 2015. So I take another object of the year 2015 and this also is a 1 rupee coin of the year 2015. then these two coins are said to be congruent to each other, because when I put one coin over the other, the thickness and the size are same. And when we look into them side by side, I only see the ear being different, but the coins are same. So this is an example of congruent coins. Congruent coins are the coins which are equal in all respects. So finally, I define congruency to be the two quantities are said to be congruent if they are equal in all respects. Equal in thickness, equal in size, equal in shape, and equal in quality is how we see the congruency. Congruency of two pictures of mine clicked, congruency of two coins which are taken of the different years. Congruency equal in all respects. So I define congruency two quantities which are equal in all respects is how I define the congruency. Two quantities which are equal in all respects are said to be congruent quantities. Congruent photos, congruent coins is how I understand the definition of congruency. Now that we have discussed about congruency of two different quantities, now comes the concept of discussing the congruency for triangles. So let's see the rules for congruency of triangles. The topic of the session, congruency of triangles. So for example, I have two triangles ABC and DEF. The two triangles are said to be congruent if they are equal in all respects, is what we have defined congruency in the previous session. Now, triangle ABC and DEF are the two triangles I have considered. Triangle ABC is said to be congruent. The symbol I use for congruent is this. Triangle ABC is congruent to triangle DEF if they are equal in all respects, in the sense that they are equal in sides, equal in angles is what we understand, or equal in area. So if the first thing for congruency is the corresponding sides of two triangles are equal. That is, for triangle ABC and triangle DEF, the corresponding sides are equal. That is, the corresponding side of AB is DE, so this must be equal to this, and for AC the corresponding side is DF, which must be equal, and the corresponding side BC and EF must be equal in correspondence. The corresponding sides are equal, and secondly, the corresponding angles are equal. The second case is the corresponding angles. Now that the corresponding sides are equal, next comes the corresponding angles. Angle A equals angle D, angle B equals angle E, angle C equals angle F. Is how we understand the corresponding angles of the two triangles being equal. this equals this, this equals this, and this equals this. So the two triangles are congruent under these two conditions. Congruency of two triangles is based on corresponding sides of the two triangles being equal and the corresponding angles of the two triangles being equal out here. Congruency defined through the symbol. Is how we understand the two triangles congruent. Congruency of triangles. Now that we have seen the rules for congruency of two triangles, let's see its applications through some applied problems. For example, I start with applications. For example, I have two triangles. Let me examine if the two triangles are congruent or not, or are not congruent. I have two triangles here which are PQR and LMN. So I have two triangles PQR and LMN which I need to identify whether they are congruent or not congruent. So let's see. 30, 60, and then this. So let's see if the two triangles PQR and LMN are congruent. Clearly, let's start with corresponding sides. So initially, I'll examine for corresponding sides in the triangle PQR and triangle LMN. I clearly have my PQ, which is 4. And similarly, my corresponding side MN is 4. So I have PQ equals MN, which equals 4, is how I understand. Similarly, let me take the next side QR. The side QR of the triangle PQR, which is 3, its corresponding side LM also is 3. Is how we understand the second side. And the corresponding side of QR is LM because the angle 30 degrees opposite to QR is QR and the angle opposite to 30 degrees is LM, which is 3. Similarly, my PR, which is opposite to the 90 degrees, because when this is 30 degrees and 60 degrees, the third angle is right angle and here is right angle. So opposite to right angle is phi and opposite to right angle is phi. Therefore, my side PR, which is the hypotenuse for this right angle triangle, and LN, which is the hypotenuse for this right angle triangle, are equal, and in turn which are equal to phi. Is how I have all the corresponding sides which are equal. The corresponding sides are investigated to be equal. Next is the corresponding angles. My angle, which is 30 degrees, is equal to angle which is 30 degrees. So here my angle P is equal to angle N, which is equal to 30 degrees. Similarly, my angle R equals, this being 90 and 30, obviously this must be 60 degrees using the angle sum. 180 minus 90 plus 30 is 60 degrees. Therefore, this angle refers to the corresponding angle out here. So my angle R is equal to angle L, which is equal to 60 degrees. Thirdly, my angle Q, which is 90 degrees, is equal to angle M, which is 90 degrees. Therefore, I have the corresponding angles equal. Are equal. Now, since for the two triangles PQR and LMN, the corresponding sides are equal and the corresponding angles are equal, therefore, I can say triangle PQR is proudly congruent to triangle LMN. So the two triangles are congruent because the corresponding sides are equal and their corresponding sides angles are equal. They are equal in all respects, therefore they are congruent. Is how I apply the congruency concept in the given problems. Applications of congruency of triangles in real life. Now that we have discussed about the rules for two triangles to be congruent or any two objects to be congruent, let's continue the session with congruency of triangles continued with more properties. Let's come out with today's introduction on CPCT. What is CPCT? Let's see the definition in brief, and then the full form of CPCT would be understood more clearly. Most of the times we use this concept or this term in proving for congruency of two triangles or congruency of two objects. So let's see in brief the CPCT property connecting the congruency of two triangles. Before we just understand this, let me take two triangles. Say for example, I have two triangles out here. Then clearly I see that the first triangle, let me denote by ABC, and my second triangle, let me denote by DEF. Then let me say this angle corresponds to this angle out here. Say my angle A corresponds to angle D. That means both the angles are equal. Then let my angle B equal to angle E and my angle C equal to angle F. Then clearly I understand that the corresponding angles are equal. I do not represent saying that A equals D, B equals F and C equals E, but there is a fixed correspondence between the angles of the first triangle and the angles of the second triangle. Angle A equals angle D, angle B equals angle E, angle C equals angle F are said to be correspondingly related angles as given in the problem. Now let's see how the corresponding sides are connected with the two triangles, triangle ABC and triangle DEF. As can be clearly seen, let's choose the side opposite to the first angle A. So here I have my side which connects to angle A. So the side which connects to angle A is BC. Now let's connect with the corresponding angle of A, we know that the corresponding angle of A is angle D. Therefore, the side opposite to that is EF, as can be clearly seen. Therefore, the side which corresponds to angle D is EF. Similarly, let's go to angle B. For angle B, the side which corresponds is AC. Therefore, its corresponding side in the other triangle DEF is understood through the corresponding angle E for angle B. So, corresponding angle of B, which is E, has its side opposite with DF. And lastly, my corresponding side to angle C is AB. So, for angle C, my side is AB, and the corresponding angle for C is angle F. Therefore, its corresponding side is DE. Now, let's see all three different cases. Since angle D is the corresponding angle for A, and angle E is the corresponding angle for angle B, and angle F is the corresponding angle for C, therefore, its corresponding sides are the corresponding sides of the two triangles. That is, when I take BC, the corresponding side of BC is EF, and the corresponding side of AC is DF, because for AC it's DF, and the corresponding side of AB is DE. Therefore, the corresponding side of this AB is DE, as can be clearly seen. This is how I understand the corresponding sides. So, like this, if the triangles are in different positions, we can easily identify the corresponding sides and the corresponding angles or the corresponding parts. So, CPCT refers to corresponding parts of congruent triangles. C, P, C and T is how I expand CPCT. The corresponding parts of congruent triangles are always equal is how we understand the CPCT. CPCT, corresponding parts of congruent triangles. Always equal. This is very important property. By CPCT, we can say the corresponding parts of congruent triangles are always equal is how I understand the CPCT connected with congruency of two triangles. For any two congruent triangles, the corresponding parts must be equal. In this case, corresponding angles and corresponding sides are always equal is how we understand the properties connected with CPCT. Now that we have discussed about congruency of two triangles or the congruency of two objects with its own rules and definitions, and the most important property which I have discussed in the previous session, the CPCT, now comes the different types of axioms which we are going to deal and study or investigate the different types of congruency of two triangles which can exist in mathematics. Investigating the congruency of two triangles with various possible properties. The first thing what I'm going to come out with the congruency axiom is SAS axiom. So let's see what SAS axiom refers to. SAS axiom is what we are going to deal with. Let's see in brief. Imagine I take two triangles and prove the congruency through SAS axiom. Before we try to take into consideration the SAS axiom, let me make a note that SAS refers to side, angle, and side. So SAS refers to side, angle, and side, and this angle is between the two sides. Is how we understand SAS side angle side axiom. Importantly to note, angle between the two sides which we take into consideration. So let's take the two triangles. Imagine I have a triangle A, B, C. And I have a triangle DEF. These two triangles, let's see if they are congruent through SAS axiom. What is SAS axiom? How do we define SAS axiom in mathematics? SAS axiom in respect to congruency of two triangles defines that if two sides and one included angle are equal in two triangles, then the two triangles must be congruent. Say for example, this side equals this side. My AB equals ED, and say for example, my side AC equals my side DF. Is how I take the two sides, one side being AB connected with ED and the other side being AC connected with DF. Now, as we have referred that the angle is the angle chosen between two sides, then clearly for these two sides, this is the angle which is chosen, and its corresponding angle here chosen between two sides must be this. This cannot be the angle because this angle does not include these two sides. Angle chosen must include the two sides between two angles to get an angle. So here is the angle which refers to two sides, and here is the angle which is included between two sides. So when these two are equal, if AB equals DE, the side AB equals DE, next AC equals DF. And angle A equals angle D. Let me write in order. Angle A equals angle D and AC equals DF. Then clearly I see that this refers to two sides being equal, and this refers to the angles being equal, and this refers to the other sides being equal. To note, this being the included angle, that is the angle which is included between the two sides chosen or considered in the problem. So here are the two sides considered, so this is the included angle in triangle ABC. Here are the two sides chosen, so this is the included angle between the two sides of the triangle DEF. So since the sides are equal, corresponding sides are equal, included angles are equal, and the corresponding sides again are equal, Therefore, by SAS axiom, I can say that the triangle ABC and the triangle DEF are congruent to each other, is how I define SAS axiom. If two sides of the two triangles are equal and their inclusive angle is also equal to each other, then we say that the two triangles are congruent by SAS axiom. Therefore, if this is this, then by SAS axiom, I say that triangle ABC is congruent to triangle DEF, is how I define SAS axiom. Two triangles are congruent if the corresponding sides are equal and their included angle is equal, is how I state SAS axiom. Two triangles are congruent if their corresponding sides are equal and their included is how I define SAS axiom. Two triangles are congruent if their corresponding sides are equal and their included angle is equal. Side angle side property. SAS axiom defines the congruency of two triangles. That's how we understand the concept. Now that we have defined SAS axiom, that two sides, corresponding two sides are equal and their included angles equal, then the two triangles are congruent. Let's see what if the angle is not an included angle. That is, if I take SSA axiom, let's see if this holds for congruency of two triangles. Side angle, that is, I take two triangles ABC and say another is DEF. Triangle ABC and DEF. Then SSA means if the side AB equals this and my side AC equals this and one of my angle is this, then I say side, and angle, where angle is not included. A is not inclusive angle. Then let's see if the congruency holds. When we have a non-included angle with AB equals DE and AC equals DF and angle C equals angle F, which is non-inclusive angle, then triangle ABC is not congruent to triangle DEF because SSA axiom doesn't hold. That implies SSA axiom does not hold for congruency of triangles is how I understand. That is, when I take the corresponding two sides of the two triangles being equal and their non-inclusive angle being equal, I cannot apply the property. SAS axiom holds, but SSA axiom does not hold, is how we understand the property. Or similarly, ASS axiom also does not hold for congruency of triangles. Is how I understand the ASS axiom does not hold for congruency of two triangles. Side angle side and congruency of triangles is true. Now that we have discussed about SAS axiom, let's now discuss about the congruency of triangles using the ASA rule or ASA axiom. What does ASA stand for? A stands for angle, S stands for side, and A stands for another angle of the triangle. Imagine there are two angles given. This side being in between two sides implies the side is the included angle, or the side which has the two angles connected is how we understand the inclusive side. Say for example, I have a triangle where these two angles are given, then ABC, given that angle A and angle B, then inclusive side between the angles is AB, is inclusive side between angle A and angle B, is how I understand the inclusive side connected with ASA axiom. A for angle, side inclusive, and this for angle, is how we understand the ASA axiom. So what does ASA axiom define? Let's see in brief through the two triangles connected with ASA rule. So let's take two triangles, triangle ABC and triangle DEF. These are the triangles, triangle ABC and triangle DEF. Now let's see the congruency through ASA axiom. Now let's say my angle A out here is equal to angle D, and my angle B out here is equal to angle E. So with the two angles being equal, my inclusive side is AB, obviously which should be equal to DE, is how I understand the inclusive sides AB and DE. Now here angle A equals angle D, angle B equals angle E, and the inclusive side is AB, which is equal to DE. This is A, this is S, and this is A. Angle, inclusive side, and angle, these three being equal, then ASA axiom says that then by ASA axiom, triangle ABC must be congruent to triangle DEF, is how we understand the ASA angle side angle axiom. Angle side angle axiom. Let's see how we can define through words. ASA axiom. If two angles of one triangle are equal to the corresponding two angles of the other triangle, and their inclusive side sides are equal, then the two triangles are congruent. Is how I understand the congruency of two triangles connected with ASA axiom, angle side angle axiom. This equals this when the corresponding angles equal and the inclusive sides are equal. That's how I define ASA axiom. Now that we have defined the ASA congruence rule or ASA axiom, let's try to connect this with angle sum property in a triangle. That is, sum of all three angles in a triangle equals 180 degrees. Let's see how we can connect to investigate the extended properties of ASA congruence rule. AAS congruency using angle sum property. Let's see how we can connect with angle sum property with AAS congruency. That is, in the previous session we have seen that when two angles of one triangle are equal to the corresponding two angles of the other triangle and the inclusive side is equal and the inclusive sides are equal, then the two triangles are congruent by ASA axiom. Now let's derive through AAS axiom connected with ASA axiom. Let me take two triangles ABC DEF. Say my side AB equals side DE, angle A equals angle D, and angle B equals angle E. Then clearly by ASA axiom, with this being the inclusive side of the two angles, by ASA axiom, the two triangles are congruent. But when I extend the property, because angle A equals angle D and angle B equals angle E, let's see what exactly we can get from the properties. Now let me first choose from triangle ABC. From triangle ABC, I clearly observe that my angle C would be connected with angle sum property, angle A plus angle B plus angle C equals 180. Then, in order that I want to find angle C in terms of angle F, let me try to bring this in the form 180 minus angle A plus angle B, with these two brought to the right. Now, angle A is equal to angle D and angle B equal to angle E. Therefore, I can write this as angle D plus angle E. Is how I get substituted through this. Now let me switch to the other triangle, triangle DEF. Here I have clearly my angle F would be 180 minus angle D plus angle E, using the angle sum property in the second triangle DEF. Therefore, 180 minus angle D plus angle E must be angle F, since by angle sum property in the two triangles. Therefore, I come to the conclusion that angle C must be equal to angle F. Therefore, they are equal. That means when two corresponding angles are equal, obviously the third angle also must be equal to the angle of the other triangle correspondingly. So using this property, we come to the conclusion that because of these two triangles being equal, the third angle obviously must be equal. Thus, the corresponding angles of the two triangles are congruent. All the three angles of the first triangle are correspondingly equal to all the three angles of the second triangle. Inclusive side, this being equal to this. Now let me just remove this. I don't want to utilize the condition of angle B equals angle E. Now let's see how the axiom reduces to AAS rule. Angle A equals angle D, angle C equals angle F as proved, and AB equals DE. AB, the non-inclusive side, the two angles here, and the side is non-inclusive, and the two angles here, the side DE being non-inclusive. Therefore, if the corresponding two angles of the two triangles are equal and the non-inclusive side is equal, also the two triangles do not lose their congruence property. Is how we understand the congruency of two triangles through AAS congruency. Therefore, AAS axiom if the corresponding two angles of the two triangles are equal and the non-inclusive side are equal and their one pair of non-inclusive sides are equal, then the two triangles must be congruent. Is how I understand the congruency through AAS axiom. is how we understand the SAS axiom. If the corresponding two angles of the two triangles are equal and one pair of non-inclusive sides are equal, then the two triangles must be congruent. The sides can be inclusive or non-inclusive. It doesn't affect the ASA or AAS axiom, is how we understand. This can also be referred as SAA, congruency rule.